Now, odds and probability are not exactly the same thing, but they're closely related. One thing you should know about odds is obviously odds can be greater than 1, whereas probability can't be, because, for instance, you could have odds that are 10 to 1, 100 to 1 odds, but obviously you couldn't have a probability that's 10 over 1 or 100 over 1. So let me just explain how this works. First of all, the probability of an event E is really the ratio that says the number of ways your event can occur over the total number of possible outcomes. But the odds in favor of that same event, now that's odds in favor of that event, is actually just a ratio of the number of ways the event can occur to the number of ways the event cannot occur. So the probability of an event and odds are related, but not the same. So let's say you wanted to convert a probability to odds. Well, let's say you're given that the probability of an event is 7 out of 11. Well, then that would mean that there's a total of 7 ways the event can occur out of 11 total possibilities. So if there's 7 ways something can occur out of 11, how many ways can it not occur? Wouldn't it just be the difference of 11 and 7, which would be 4? That's correct. So there's 4 ways it cannot occur. So the odds in favor of the event would be 7 ways it could occur to the 4 ways it could not occur. And you could write it as a fraction, or you could write it like this, 7 with a colon 4, or you could just use the word 2 4, 7 2 4. But those are all 3 common ways to express odds. Here's another example. Again, the probability is given as 8 out of 31. And so if there's 8 ways the event can occur out of 31 total, then subtract 8 from 31 and you get 23 ways the event cannot occur. So therefore the odds in favor of the event would be 8 to 23. Now if you wanted the odds against it, the event occurring, you just switch those around and say 23 to 8. So now, what if you wanted to convert odds to probability? So suppose the odds in favor of a team winning a game are 7 to 5. Well, that means there's 7 ways to win the game to 5 ways not to win the game. Well, if you think about that, that means that implies that there's 12 possibilities. 7 plus 5 is 12. So the probability for winning the game would be just 7 over the sum of these numbers, 7 over 12. So the probability would be 7 over 12. Now, I just used common sense to explain those problems, but actually there are formulas that you can use. If you want to find, if you're given the probability of an event here and you want to find the odds in favor of the event, you can simply take the probability of an event divided by the probability of not the event, in other words, the probability of E divided by the probability of E prime, and then simplify that. That'll give you the odds. So for example, if you have a probability of 7/9, well then you know the probability of not the event would be 2/9. 1 minus 7/9 is 2/9. So then the odds in favor would be 7/9 divided by 2/9, and if you simplify that, you get 7 over 2. So the odds in favor would be 7 to 2, and then again, if you want the odds against, just flip it around, it would be 2 to 7. Now, if you want to convert odds to probability, then the formula is if you're given that the odds are A to B, then the probability of the event is A over A plus B. So if you know the odds are 8 to 5, then to get the probability of the event, you just do 8 over 8 plus 5, which is 8/13. Now again, you don't really need the formulas if you understand how odds and probability are related, but they are helpful. So let's finish up here with a couple of examples. Suppose there's a 30% chance of rain tomorrow. find the odds in favor of rain. Well, using the formula, I can say, well, there's a 30% chance of rain, so the probability of rain is 0.3. Therefore, the probability of not rain is 0.7, which is 3/10 over 7/10. So the odds in favor of rain is 3 to 7. And then, of course, the odds against rain would be 7 to 3. Now, this one says find the odds in favor of rolling a sum of a 7 on a pair of dice. Well, the probability of rolling a sum of 7, remember there's 6 ways out of 36, or 1 out of 6 ways to roll a sum of 7. So the odds in favor would simply be 1 out of 6 divided by 5 out of 6, or 1 to 5. So in other words, there's one way to roll a 7 to every 5 ways not to roll a 7. Now, if you want to use the formula to get the odds, if you want to use the formula to get the probability given the odds, let's say that the odds in favor of a horse winning a race is 4/5. What's the probability of the horse winning the race? Well, that would just be 4 over 4 plus 5, which is 4/9. And then if you want the probability of the horse not winning the race, then you would just flip that around, make it 5 to 4, and then your probability would be 5 over 4 plus 5, which is 5/9. And then I'll end with this problem. From a telephone survey of 1,000 people, it was found that 500 people had tried soda A, 600 tried soda B, and 200 had tried both. If a person from the pool is surveyed, randomly selected, what's the probability the person has tried soda A or soda B? And then find the odds in favor of the person trying soda A or soda B. So we can just calculate the probability. That's just the probability of a union. So if you do your little Venn diagram down here, make it a little bit smaller. So if you do your Venn diagram, then what's going to happen here is, you know, you've got 1,000 people, and 500 tried soda A, 600 tried soda B, and 200 tried both. So if you take 200 from 500, then 300 tried only soda A. If you take 200 from 600, then 400 tried only soda B. And then if you add these together, 300 plus 200, 400, that gives you 900. And if you take 900 away from 1,000, that leaves 100 that didn't try either. So now if you think about it, let's find the probability that they tried A or B. So look, there's 300 plus 200 plus 400, so that would be 900 out of 1,000, or 9/10. Now, so the probability of A union B is 9 out of 10. So the odds in favor of that would be the 9 ways that you could get the event to the 1 way not to get the event. And so the odds in favor would be 9 to 1. B says, what is the probability that the person has tried only one of the sodas? Well, 300 here tried only soda A, and 400 here tried only soda B. So that's 700 out of 1,000, or 7/10. But to calculate the odds, that would be 7 to 3. So 7 ways to try the soda to the 3 ways not to try. All right, then what is the probability that the person has tried none of the sodas? Well, that's the 100 here out of 1,000. So that would be 100 over 1,000, which reduces to 1 out of 10. So the odds in favor there would be 1 to 9. Now I'm going to end this with just a note about the law of large numbers. Basically, in mathematics, the law of large numbers, it states that the approximate empirical probability can be made as close to the actual probability as we please by making the sample sufficiently large. So, you know, that makes sense, because if you've got a sample population, if you take a sample of your population, then you might get a certain percentage of people that feel a certain way, but the more and more people that you choose in your sample, then you should get closer and closer to the actual probability that's true of the entire sample. So in the next section, we're going to discuss expectations of a probability distribution. And if you know what to expect in a large number of trials, you know when something is not right in your data.